Hi, everybody. I hope you're enjoying Remars, and thank you for taking the time to join us today for our talk. I'm Sri Ganesan, Head of Software Products at Habana Labs, and today I'll be also joined by Jonathan Luce and Eric Nieves. We're going to be talking about the democratization of technology and how Intel is working with our partners to enable the same with some of these emerging technologies. So let's start with what we mean by democratization of technologies. We're talking about both cloud and the edge. In terms of putting the technologies in the hands of the users, the practitioners, and those who are also going to be the emergent practitioners, there are several vectors here. One is affordability. You need to make it such that they can get access to it, that it's cheaper, that enough practitioners and enough businesses and developers can actually play with these technologies and start using them to solve some of the problems for larger scale, for the world, but also for their own smaller problems which they're targeting for their businesses and for their people, whether it's public sector, private sector. In terms of making it accessible, it's not just the hardware. We want to make sure both the hardware and the software is accessible. You're putting it, again, in the hands of people who are going to use it in the most effective way. We don't have to stop with just those two, because we also have to train and empower our developers and practitioners again, and that's where the education aspect comes in. And the last part is propagation and making sure that we're able to scale it across to more industries, more businesses, more organizations, so they can take advantage. And that's how we see democratization playing out. So I'm going to start with focusing on AI. We believe AI is one of the most transformational technologies out there. Intel has a lot of assets across our portfolio. I'm going to be focusing on the Habana AI training processor, and we're going to talk about how we're democratizing AI through cost efficiency using Habana's Gaudi processor as an example. So you will see here that a recent IDC study reported about 56% of the AI/ML customers saying that the cost is their most significant barrier to adopting AI. And for them to actually take and deploy it, some of them are using retraining and running their models, like 74% of them are doing it weekly, or half of them are doing it daily. So there's a lot of iterations of training that are happening. So as an industry, it's our challenge. How do we actually provide customers and businesses and organizations access to more affordable training? And this is where Habana Gaudi comes in. It's been designed from the ground up for cost efficiency. And here you'll see that this is just a picture of our OAM form factor. So Gaudi is a purpose-built AI training accelerator. It's got a cluster of tensor processing cores. It's got a configurable matrix math engine. It's got a software managed memory. We have 32 gigabytes of HBM that's available. It's very different from a general purpose architecture, and it's designed specifically for training efficiencies, and more specifically in terms of AI training, it's for deep learning training. The other unique thing that you'll notice about Gaudi is that it has integrated 10 ports of 100 gigabit Ethernet on the device itself. So for a deep learning training, it's not sufficient to do training on a single device. Usually it's like a distributed training. We're seeing a lot of growth in large-scale models, large-scale training. So enabling scaling efficiency is one of the most critical pieces of enabling better, efficient training. So by integrating these ports on die, we're allowing you to scale out very efficiently with Gaudi. Now, the unique other factor is the fact that we're using standard Ethernet protocols. This is using the RoCE v2 protocol. It's a standard Ethernet protocol, so it's not something that's a proprietary protocol. You're using, you can scale out, and you're not locked into specific vendor interfaces. And in terms of building out a cluster, if you're building out a large number of nodes and connecting them together, all you need is standard Ethernet switches. So what happens is that you have also reduced the number of discrete components, and therefore there's savings in terms of both power and cost. And all of that cost savings is basically translated back to the end users. Gaudi is built on a 16 nanometer process, and the fact that it's purpose-built in terms of its architecture for deep learning training efficiency allows us to actually give significant cost performance savings, and we'll show you in a little bit some of that. So in this slide, We've got Gaudi-based EC2 DL1 instances that we're comparing against some of the other training instances. And you'll notice that we've compared it against the A100 80 gig instance, the A100 40 gig instance, and the V100 instances. And you have up to 40% better price performance with the Gaudi DL1 instances compared to the GPU-based instances. So on the left, you'll see the pictures showing the chart showing ResNet 50 as a proxy for vision models, and on the right, you see the picture of BERT Large as a proxy for NLP or language models. And you can see that for A100, it's in the 45–50% range, and then as you go to the V100 and compare against that, you get up to 75% and 77%. So on BERT, I've got two pictures here. Phase 1 and Phase 2 have different training regimes, so just wanted to highlight that obviously it depends on the training regime and the kind of training that you're doing, and you still get a lot of savings from using Gaudi-based DL1 instances. And this is the cost savings that you can expect. This is on a single instance, and if you have distributed training, you get the multiplier effect with that. We're also very excited to announce the availability of Gaudi 2. In May, we announced that we have our next generation processor, and it has leadership performance. You'll see again two charts, ResNet 50 for vision and BERT representing the language models as a proxy. And we are nearly 2x better in terms of throughput compared with the A100 GPUs. And we are very excited that we have this next generation product. It's building on the same architecture. It has just more matrix math engine is more. The TPC cores are higher. We have more scale out ports. We have more HBM memory available, and the same cost efficiency that you get will be available on Gaudi 2 as well. So I want to talk about a couple of examples of our end customers who are using Gaudi and taking advantage of the cost efficiency of Gaudi. And this is just to show you what's possible. This is just a sampling of customers that we are going to show you here. The first one is Mobileye. Mobileye is a company that is driving the evolution from assisted driving to autonomous driving. They're an Intel company. And we've been working with them on enabling some of their training workloads with Gaudi on DL1. You'll notice in the picture of the car that there is a bunch of cameras on the car, so they're capturing a lot of image data, and doing custom object detection, 2D and 3D models that are getting trained on Gaudi. And multiple teams are now starting to use DL1 in the Mobileye team. They have seen more than the 40% price performance improvement that we reported earlier with some of the vanilla workloads. We have also started working with them some of the larger scale models to allow them to get better time to market, right? So this allows them to actually put their cars on the road, which are safer, allows us to make the transition to autonomous driving more faster, and empowers more what we can get out of the AV space by partnering with a company like Mobileye. And we hope that other AV companies can take advantage of the similar capabilities that Gaudi offers. And hopefully we'll see in the future more excitement with the AV space. The second example here is Leidos. This is another partner. They work a lot with the government agencies like FDA, NIH, and CDC. We focused on healthcare applications with them, which is very different from the AV space. In this case, we took the scenario in the context of the pandemic. There's a lot of work, a lot of research, and a lot of activity that was going on in terms of how do we handle, diagnose, and treat COVID. They wanted to use frontal chest X-rays to basically detect COVID pneumonia using deep learning. They were able to see 60% cost savings with just switching from a P3DN instance to a DL1 instance. And so they were very excited to then start taking this and then scaling it out to more of their end users and customers. For us, I mean, for me personally, and for us as such, I think this growth in AI adoption in the healthcare space was going to continue. COVID was the inflection point where this just picked up. It's actually very exciting and rewarding to be able to offer cost-efficient technologies like DL1 to be able to solve some of these very challenging problems, reducing the time to diagnosis, time to cure, and enabling the world become a better place. And it's actually rewarding to be working on this. I want to show you a brief testimonial from one of our partners in Leidos. Hopefully you can hear this.
For the past 2 years, our customers in federal health and medical community have been racing against COVID, from diagnosing the disease to devising treatments and vaccines. The race continues worldwide as COVID continues to morph, and there is new data collected every day to inform diagnosis and cures for the new variants. One key benefit that faster time to train can provide is early detection of the presence of COVID in patients. If physicians can detect the disease at early onset, they can prescribe oral medications that can prevent hospitalization. Early detection is the key to minimize severe effects of COVID on patients and getting them healthy as quickly as possible. For this reason, faster time to train can mean faster time to recovery at home. So at Leidos, we are looking forward to bringing Gaudi 2's performance to our federal health customers like the FDA, NIH, and CDC, and medical practitioners and researchers to help them mitigate severe outcomes and predict and prevent outbreaks. Thank you.
So the other one I wanted to highlight is our work with San Diego Supercomputing Center. We have a Gaudi cluster called Voyager. It just went live. There's a 3-year testbed phase, and during which they're opening it up to researchers and institutions to come in and start doing some of their research with deep learning on this Voyager cluster. So this is the next set of solutions, next set of ideas that these researchers and teams are working on, and hopefully we'll be taking advantage of the uniqueness of Gaudi and being able to solve these problems in a different and better way. So it allows the next generation of problem solvers to take advantage of Gaudi. I just got a simple example here of how they've already used Gaudi here. So this is in the context of wildfire management. They've been using DL algorithms to look at satellite images and determine land cover across different types of geographies and address the threat of wildfires, especially in terms of where there's populations and impact possible. And they've been using Gaudi to go and solve this problem with deep learning. And we're very excited to be partnering with the San Diego Supercomputing Center to enable researchers and scientists solve the next set of problems using Gaudi. So that talked about the hardware part of it, the fact that, again, we have access through a public cloud instance like AWS, the fact that we have Voyager for universities and researchers to work on it democratizes the access to the hardware, but that's only one piece of it. We have to also democratize the access to the software. So I'm going to spend a little time talking about how we're making that happen. So the bottom of the stack over here is Synapse AI. It's purpose-built, again, to get optimized models running on Gaudi. So it takes the neural network representation, that topology, and we basically convert it into a recipe that can run most efficiently on Gaudi. So that's very hardware specific, and all of these compiler optimizations are happening specifically for our hardware. But at the end of the day, the data scientists and developers are working with some of these open source tools like PyTorch and TensorFlow. These are the popular frameworks they're using. So we wanted to make sure that we empower the developers and data scientists to be comfortable using the same programming paradigms that they are used to, not having to change anything on them. So Synapse AI, which is our software stack, is integrated into TensorFlow and PyTorch. Now, since then, we've also done more work in terms of trying to meet developers where they are, because there's a lot of new ideas and new research that's going on. These get quickly turned into Python libraries or lightweight frameworks and developer tools, and developers are taking advantage of the productivity that those tools and libraries offer. So we've started working with ecosystem partners in terms of connecting with these developer tools and libraries and frameworks, in addition to just having the deep learning frameworks like TensorFlow and PyTorch support. And I'll talk to you in a moment about the couple of partnerships and highlight them. So I want to call out 3 partnerships over here. We're working with Hugging Face, a very popular repository. This is a very it's like they call it the GitHub of the models out there. So they started out with NLP, now they've expanded into many other areas, computer vision and other areas. This is a transformer-based library, extremely popular. They've democratized access to models through their approach with working with developers and making it easy for them to take advantage of these models. We recently partnered with them to integrate Synapse AI into the Optimum library, and we've got the Habana Optimum library, where you can basically quickly take any transformer model that's available on Hugging Face and be able to deploy it and run it and train on Gaudi. So that's something that we're very excited to be continuing to work with the Hugging Face team. And this allows us to, again, reach a vast number of developers with tools and libraries, again, that they're familiar with and comfortable with. The second one is PyTorch Lightning. PyTorch Lightning is another very popular framework. It's an abstraction on top of PyTorch. There's a lot of boilerplate code that gets written in PyTorch. Not every data scientist needs to worry about how these things get implemented. So Lightning offers a wrapper on top of it to make it simpler to focus on the data science and research aspect and worry less about actually the details of how it gets implemented in PyTorch. And it's, a very popular lightweight framework. So we've been working with the PyTorch Lightning team. We've integrated Synapse AI into PyTorch Lightning as well. So today you can go and install PyTorch Lightning and start working with Gaudi and take advantage of the features of Lightning. And the third one here is Converge.io. It's an MLOps platform. And this is something where whether you are a data scientist or a developer or an IT infrastructure owner, there are different types of problems you're solving in an enterprise. And MLOps for AI is one of the key areas where you can actually make it very easy in terms of managing experiments, in terms of versioning your experiments, building up workflows where you can then try different types of models and try hyperparameter tuning, and build out your pipeline all the way through from your data ingestion through to inference. And we've also integrated Gaudi with Converge.io. It's both available on premises if you have Gaudi available on premises, or you want a cloud burst to DL1. You can do both. It's agnostic. Converge.io allows you to continue to use your existing infrastructure and also take advantage of DL1. So where it is appropriate, you can take advantage of Gaudi. So the reason to reiterate, the reason we're working with these partners is because we're trying to be as close as possible to the developers, and we'll continue to have these types of partnerships where we can actually empower developers to take advantage of whatever's available in the ecosystem, in addition to taking advantage of the benefits of Gaudi. So the other aspect in terms of software accessibility is not just integration of Synapse AI and making it available, it's also how easy it is to use, because there is this barrier in terms of taking advantage of a new architecture and a new software stack. So we've spent a lot of time trying to reduce the amount of investment that we expect end users and developers to make. We've focused a lot on providing developer assets on our developer site. You can go to developer.habana.ai. You can find a lot of resources there's obviously user guides and training materials. There's small tutorials which are easy to consume. For those who like video tutorials, we've got video tutorials. So different types of learners have different approaches working with different assets. We've also got a reference model repository. We've got 40 plus models that are very popular CV and NLP models that have been ported over to Gaudi, so you can go in there and start running these popular models and start training with your own data sets and take advantage of Gaudi easily. It's also a reference, so you can look at what kind of changes you need to make. And we've got the developer site, the forum, and our GitHub for support. So the next question I usually get is what does it mean to actually make it work on Gaudi? So I wanted to show you how simple we've tried to make the changes. This is a very simple example of training an MNIST model using MNIST data set with a small neural network model. You need to insert 2 lines of code where you load the Habana module and you invoke it, and that basically, this is a TensorFlow example where it tells the framework that there's a device called the HPU, which is the Habana processing unit. That's how we refer to Gaudi in the frameworks. And it allows you to start prioritizing the operations to get executed on Gaudi. Basically, our Synapse AI software stack will take the computation graph from the framework, identify the subgraph that can get accelerated on Gaudi, and then basically schedule it for execution, do the optimizations and schedule it. And if there are operators that we don't support, it'll just fall back to the CPU, and you'll take advantage of Gaudi wherever it's possible, and the rest of it is going to execute without issues. So I wanted to also highlight a couple of more use cases. We have several customers. I cannot describe details about each customer, but we have customers working on industrial defect detection, using Gaudi for fraud detection and inventory management in retail. Obviously, we've talked about 2D and 3D medical imaging use cases. And in the autonomous vehicle space, we've talked about segmentation. And we've got several customers using NLP, BERT-like models and vision transformers. They're using it for different NLP use cases, sentiment analysis, question answer, subject matter query. So these are the 4 few areas where we have customers actually exploring and using Gaudi and taking advantage of the cost savings that they can get with Gaudi. I'm going to then switch to the third vector, which was democratization through education. So it is, again, not enough to just have the democratization in terms of affordability, in terms of the access. We also need to train the next generation of users, and the current generation of users who are familiar with a different platform, make sure they're effective in taking advantage of these technologies. So we've been spending a lot of effort in educating the developer community. There's a lot of how-to trainings. We've got open online courses. We've got workshops, hackathons, lots of hands-on training that we're making available to our developer community, and ensuring that they're effective and productive with our Gaudi platform. And on a broader scale, I want to also touch upon some of the work that Intel is doing with other areas in AI, where we're working with to enable underserved students and underrepresented minorities to have that access. This diversity is another important piece for us. It's very critical. We care deeply about it. So AWS and Intel's Deep Racer Student League is one of the ones that I'm calling out here. It's a fun way for underserved students to come in and get started and learn about Gaudi. They get many hours of educational material. They get free time to kind of computer resources to do their learn and train and up-level their skills. There's monthly prizes that's available to them, scholarships, and they have devices. So this is how we hope it's a path for these underserved students to learn and grow skills, and for some of them can qualify to earn a Udacity Nano Degree scholarship as well through the AWS AI ML Scholarship Program. The second one I want to call out, something that I'm very passionate about, is Intel continuing to invest with Girls in Tech. This is a nonprofit that has been focused on STEM and making sure that they're closing the gender gap in tech. The thing I'd invite you to is please come to our Intel booth and participate. When you do that, you can raise up to $10K, which we will provide to Girls in Tech to fund programs like hackathons and career fairs and other STEM-focused activities, boot camps. So I'd invite you to please come down to the tech showcase and stop by our Intel booth. This is something that is very important for us in the AI space, to build out this diverse, capable set of users beyond who we have today. So with that, I'm going to switch over and invite Jonathan to come over and talk about automation and robotics.
All right, thank you. Hi, everybody. Sorry for being too loud here. Can you guys hear me okay? All right. So my name's Jonathan Luce. I work in the Industrial Solutions Division of Intel. I run that group, and so my background's in manufacturing and manufacturing tech. I spend a lot of time with plant manager discussions and technology discussions around manufacturing. So I wanted to touch on that a little bit about what's going on. And I think I'd start off with probably in the conversations I've had with plant managers 3 years ago, you ask them what's important, and they would say, my plant has to be secure, it has to be reliable, has to be uptime, I have to have the safety of my personnel and the equipment covered, reliability. And then they say, once that's covered, how efficiently can I run my operation? And then this little thing called the pandemic happened. And for those that experienced it, which we all did, I learned about the implications of the supply chain in some unusual ways. When I talked to plant managers, I got some calls from a senior VP of a pulp and paper company who said, hey, people are doing their business at home a lot more now instead of at work, because they're not at work. And so the implications of that from a paper company are big offices have big rolls of toilet paper. Home toilet paper is this big. And the plants are designed to produce one or the other. And the whole demographic and supply chain shift happened. And this person called me up and said, we got a ton of these extra big rolls and we can't produce enough because of the great toilet paper run of 2020 that everybody had. And we need to get agility and flexibility into our manufacturing plans. And that kind of single phone call kicked off a series of conversations of very similar themes around supply chain shortages and the perspective around what's important going forward. So when I talk to plant managers these days, when they talk about technology and how it can help them, there's still security and reliability and performance and safety, but now agility and the ability to address shortages that happen now on a global scale and on a local scale in different ways is now a priority. So the technology that normally would have happened over the course of a decade or longer is now happening a lot faster. And so these supply chain interruptions, these labor shortages, the changing customer demands as far as small versus large rolls of toilet paper, it really causes companies to think about manufacturing in different ways where they have to be more agile and resilient to these changes. And the business is going to require, the manufacturing is going to require different sets of data and different ways of doing things to be able to accomplish those goals. And so it's really kind of interesting how this transformation has really impacted technology, because the amount of data and analytics to be able to do quality control as they bring a new plant product up to speed in a plant. Anybody that's been in a plant for a long time knows that when you kind of optimize and train your production, you tune it, and it turns into a well-oiled machine, and you just run it and run it and run it and run it. But when you go and start switching product lines over, you need really good data sets to optimize and learn and reduce defect detection. So these technology creates huge opportunities that we've been participating in relative to the application of new robotics, new machine learning, new AI that goes in to that. So I'll talk about and touch on that a little bit as we go. And the other interesting thing that VP of Pulp and Paper Company told me was his productivity actually went up in his plant when they got rid of the non-essential employees, which was another interesting side effect of their learning. We don't want to go back to the way it was. We want to keep the non-essential employees out of the factory and keep the essential productivity focused on the task at hand. So very interesting trends accelerating these automation adoptions. And so when I think about the need, right, it's primarily for me, it's focused on industrial. I have sister groups in retail and hospitality that are also looking at these types of things. The approach really is around factory automation, factory supply, robotics. When you get to robotics, there's fixed and mobile robotics that come in. When you deal with robotics into manufacturing, the AMR stuff that you saw like Proteus today was a very interesting next generation perspective. But the demand is really driven by a couple of key operational themes, right? These plant managers are driven by labor shortages. They want to have the yields up. They want defect detection. They want to know and understand how to produce the products that they're chartered to go produce in the least the most efficient way, the least inefficient way. And so when I thought about some of the technologies that go into this, we really think about these technology drivers, and for me, it all starts with, for me being a chip guy at Intel, it starts with the silicon, and there's a real-time component of it that goes in relative to time-sensitive data, having the compute engines to do the management of the data in a way that your production latency is not compromised. And what that ends up doing is creating an interesting edge, right, which creates this private cloud. So when we talk about the cloud, 5 years ago I said, all the data goes up for manufacturing excellence up to the cloud, they analyze it, they figure out what they should do differently, solve the business conversations, then move it back down to production. The reality is there's a step in between that's time sensitive. And this time sensitive is what we would call as hybrid or edge private cloud that kind of is the host for a lot of these data sensing and data compute applications that go into the technology. But there is a regional and public data center cloud that goes in. And so for me, as a manufacturing guy, the technology driver that really dictates where all this compute is really the latency of the data and the speed in which you can move it up and out of the factory, out of the sensor, out of the control unit and into the cloud and back. And if you can get it there fast enough, analyze it, it's way more economical in the cloud than it is at the edge from an economies of scale as far as computational capabilities. So the optimization here is not only having ubiquitous computing, the ability to process the data no matter where you are in the edge to cloud, but it's also having pervasive connectivity, right, where you have these reliable connected devices from edge to cloud and go in. Like anybody who knows anything about factories, the last thing you want to do is have an alarm take any extra period of time to get to the operator indicating there's something going wrong with their plant, right? That is very time sensitive, and you want to make sure that your architecture and everything that comes in here goes in and absolutely has a time sensitive component to it. And when you do that, it kind of opens up different applications. So when these customers come to us from a technology point of view, especially when you think about robotics, I'll give a couple of robotics examples in this type of scenario. Let's take welding automation, right? Welders, robotic welders in automotive. So you have a company like Audi that produces 1,000 cars a day on their production line, and they say, well, here's my reality today. Plant manager of Audi comes and says, well, we pull one car a day off the line to do quality inspections of the welds. And the other 999 go downstream, and when they do further quality assessments of the cars as their normal production, maybe they find faults or failures and they do rework and everything, and that's very expensive. And they came to us and said, well, we do 5,000 welds per car and 1,000 cars per day. That's 5 million welds a day. And when you think of the different alloys that make up a car, different plies of aluminum and other composites, when they get welded together, they're not exactly the same, so a single welding application is typically overdone, right? And what they wanted to do was say, we got to solve for this to say, how do we get that quality inspection in line? Now, don't pull it out of the line to go inspect it. How do we get it in line? So we worked with them on some time series data. In this particular case, this welding application started off as a robotic welder that had a current and voltage flow, and it would go in and do the spot welds. And the reaction of the weld based on the dynamic of the training of the AI system would indicate whether it needed to be adjusted or not. So it turned into an inline adjustment of the control loop that goes in. And long story short, what ended up happening was the welding situation went from inspecting 5,000 welds a day to 5 million welds a day with adjustments on the fly, and defects went down by, something like 90%. Downstream reduction, which was an incredible savings for them. That started off, and then John Deere heard about this, and they hit us up and said, well, we've got robotic welding for our John Deere farming equipment. We've got an issue with porosity, and porosity are those little tiny microscopic air bubbles that go into a weld bead that a human has a hard time detecting, and that weakens the weld and then obviously creates quality issues downstream. So then that came, how do we solve that? Well, that's where machine vision comes in. Instead of having time series data, you start getting into machine vision data. The whole point is as you add these technologies in, the data gets exploded, there's new quality associations that come out of here, and the net effect of the customers is a tremendous improvement in the quality of their output. And so when you have that, that's great. When you have to have an agile manufacturing that goes with it, you now have to have a system that's more software defined than hardware defined. And that's where these technologies are in the journey today, is having a more agile ability to adapt. And that's where some of the things that Sri was talking about relative to training and retraining and being able to deploy those technologies becomes so critical in these technologies that go in. So really, the full potential of this entire conversation, at least from my chapter, really is all about when you pull the technologies of AI, machine vision, time series data, you add robotics, fixed and mobile, you add the networking components from the edge to cloud and all the sensors for control, you really have to pull that together as an entire solution when you think about solving for some of these business drivers and the technologies that go with it. And to realize the full potential, you really have to take advantage of all those assets that come in. It's a great opportunity, and it's also very complex, as I think the opening keynote was saying this morning. Was his name Ty? I think was his name. Yeah, thank you. Ty was saying, complex is hard, simple is harder. Thank you. I even screwed it up just like he did on that second time. But basically, we're in a situation where you've got to have the tools that go with this and be able to understand what your data objectives are, right? So when you get into what the effect of this is, this creates enormous volumes of data. And for an end user, the biggest challenge they have for that is the volume of data, the variety of data, the veracity, the ambiguity of the data. Some of the data is good, some of the data is bad. This creates huge problems for an operational technology to figure out how to deal with this. So one of the biggest things you've got to do from a technology point of view is have a good data management plan, if you will, understanding what data is important, what data needs to be processed immediately, what data needs to be put up to the cloud, and that ends up being a big part of the success of applying technology in the future. The last thing I really wanted to talk about was the analytics of defect detection. Like when I mentioned the Audi or the John Deere situation as examples, the biggest and most important part of that wasn't necessarily just defect detection, but it was also the ability to put that in line and act on it as a control loop in the system, right? It's very important that you don't just use this defect detection and then not make process changes to your production, right? That is part of where the gains are huge in this thing. So an ability to have a scheme that says, how do I take things that were offline quality control, put them in line, take all the sensory data that you have to go capture, act on it, think on it, act on it, make some changes, improve your output of that. So lots of amazing technologies out there. I think you've heard a lot about them. I think if you ever want to have some chats about some of the manufacturing technologies out there, I'll be around. For now, I'm going to close with this and then introduce Eric Nieves, who is going to talk to us from a Plus One Robotics perspective.
Thanks, Jonathan. So, Jonathan is right that a lot of this started in the manufacturing space, and even today, the vast majority of the robots that have been deployed in the last 40 years have all been in manufacturing, specifically in automotive, right? But it's been in the last 5, 6, 7 years that it's been clear that robotics was going to grow well beyond manufacturing. And that's the reason Amazon can pull off a robotics conference, right? Because as Ty pointed out this morning, they've deployed over 500,000 robots now, right? Jonathan is right that it's all of these elements Right? Everything in robotics is a systems problem. Everything. And it is perception, right? So the sensing. This is just an example of sort of our architecture, and you can see that there's an industrial robot, and that robot's going to have an end effector or a gripper of some sort, but it needs to see. This is the fundamental difference between the manufacturing world and the logistics and supply chain automation world. In the manufacturing context, it needs to do the same thing, the same way, every time for the next 4 to 8 years, or until there is some major change of going from big rolls to little rolls. Right? But in the warehouse, you can't plan on repeatability. The warehouse automation problem is one predicated on variability, because I don't know what's going to come down the line next. And we sure don't know what's going to happen next week. So it's all built around perception. You have to discover everything, every cycle. Right? And so, yes, there is a sense. Right? You take those sensors, and you do not want to do computer vision in the cloud. It's way too much latency. You have to do that at the edge. And so that's what you see there, right? There's going to be an industrial PC. It's going to be, GPU enabled, there's going to be accelerators, we're doing all of the AI lifting there. And then there's going to be a cloud component as well, which we're going to talk about, and then ultimately a human in the loop. It takes all of those. And the reason that you're seeing warehouse automation become a thing is because all of these technologies have finally come to bear in a cost-effective fashion. Right? The robot arm has been available for 30 years, but computer vision wasn't, and neither were the AI models necessary. Right? All right. That's the reason that last year, for the very first time, more industrial robots were sold outside the automotive market than within. That had never happened before. And I expect this is going to be the new normal. It's the other spaces beyond manufacturing that are going to be the large consumers of automation. And it's not just going to be the warehouse. You see, I saw the Miso Robotics people out on the floor, right? There's going to be food prep robots and everything that we're talking about in, medical devices, et cetera. Robot technologies are going to become embedded in lots of different facets around us, to the point where the robotics as a technology is going to recede. We won't think of them as robots, but it is effectively these elements. It's perception, it's some sort of decision making, and then actuation, right? So this is what I think about in democratization, right? We've talked about democratization from accessibility and other things, but the last thing Sri talked about was propagation. The robots have to go solve problems in the world. These are jobs to be done. And this is effectively all the things that we've talked about. This is an industrial robot that's tied to a set of RealSense cameras, and you'll notice that, look at the one on the upper right. It's picking from one tote, what we'll call a donor tote, and placing into the order tote. And it might be segmented so that there's 4 orders, in 4 different segments. Right? There are, in fact, 2 sets of cameras here. One of them is over the picking zone, and one of them is over the placement zone, because you need to validate on both sides of that. 3D sensing has finally come down in cost sufficiently that you can afford to do a closed loop system like this. Previous instances of 3D technology were so cost prohibitive, if you could afford it at all, you would only be able to do it one place, over the pick. And you would never really know if you did it the right way on the place side. So democratization, cost is a part of that. Right? The other is, as Ty pointed out, you have mobile robots and you have manipulators. Right? What, have they deployed 500,000 now, AMRs, within Amazon facilities? Well, it's because every workflow in a warehouse is some combination of mobility and manipulation, right? It's either somebody was dragging a cart, pushing a cart somewhere, and then a person, unloaded and packed, etc. So what we're beginning to see is what you're seeing on the upper left, which is a combination of, yes, there's a robot, and yes, there's a machine vision, and it's doing barcode scanning. That's the sort of motion that you're seeing, because you need to tie the physical assets now to their data footprint, right? So it'll scan, and now it's loading mobile robots, and then the mobile robots go and sort into the world. So reminiscent of what you saw this morning in the keynote of fixed robots loading mobile robots, because at the end, the job to be done is some combination of mobility and manipulation, which ought not surprise us, because we built our processes around our capabilities, and we are mobile manipulators, right? So that's what's happening here. But I want to back up to this, right? Because we said that there was a cloud component, but all the way to the left is this human in the loop. And this is something that we feel strongly about. And that's this. For all of our work in AI, for all the, however clever we might be, for all of the assets that we're going to bring to bear to this problem, you are a better 3D sensor than any camera. And you are much better at inference than any computer vision system. So at some point, at some level in the real world of the messy warehouse, everything from the robot to the sensors to the edge compute to the AI fails you. You don't reach confidence threshold. And what are you going to do then? Well, you could just say, okay, well, I guess we just had an exception that time. I'll hope to catch it the next time. No, that's not the way the world works. You have to be able to continue to do it. So instead, what happens is when the AI does not reach confidence threshold, right? Whether it's the AI pipeline or the 3D pipeline or the 2D pipeline, none of them said, we see and understand. Then it raises its hand over the cloud, right? And at the other end of that cloud, there is a person. And the person said, oh yeah, that's a mess. I think I would do that. Pick that up. And the robot will say, thank you very much, go back to work, and you may not hear from that robot again for some duration. What just happened? You had a human in the loop deal with the exception. What do you now have in your hand? The most valuable piece of data you could have. An exception that was captured. So obviously all of that goes back in and feeds the reinforcement learning model, and you anticipate less and less instances of that human intervention for that use case. So, when we talk about robots and edge and cloud, add human, because you really do want to have it be all four elements. That's how you get the reliability and scalability across the system. With that, we have just a couple of minutes, but we're going to invite you to come down to the Intel booth downstairs, and you can get your hands on all of these pieces. Sri will be there and her team talking about Gaudi. You can see the RealSense cameras that we use, and we'll be there, I'll be there myself, demonstrating how we do this human-in-the-loop intervention and how it feeds the AI models. And you'll be able to control a robot 2,000 miles away in Texas from right here at the floor at REMARS. So we're going to invite you, if you do have questions, just meet Sri or Jonathan and I outside the door, and we're going to invite you to complete the survey and come see us downstairs. With that, we appreciate you. All right.